Welcome to Study Loop.
For this problem on the topic of satellite motion, we are asked to describe the potential energy variations of a satellite when its trajectory is circular compared to when the trajectory is elliptical. Now, we know that the potential energy of a satellite, U, is given by minus g m1 m2 over r, where m1 and m2 are the masses of the satellite and the Earth in this case, and r is the distance from the satellite to the center of the Earth. So first let's look at a circular orbit. For a circular orbit, we know that the distance between the satellite and the center of the Earth, in one case r1, in any other case r2, is always the same. So the separation between the center of mass of the Earth and the center of the satellite is always the same. So if R1 is equal to R2 at all points, that means there are no variations in the potential energy. So U1 is always equal to U2. But what happens if the orbit of the satellite is elliptical? Well, let's look at the first case. At the closest approach, we'll call the radius of the orbit R1. At the longest approach, or the furthest distance in its elliptical orbit, we'll call the distance of the satellite to the center of the Earth R2. Now we can clearly see that R1 is less than R2. And this means that the potential energy, since the potential energy is inversely proportional to the radius, so the potential energy at the gravitational potential energy at point 1, U1, is greater than the gravitational potential energy at point 2. So U1 is greater than U2.